So let's start off with the general pattern and structure of DNA. Depending on how closely you zoom in or zoom out, there are more micro scale patterns or more macro scale patterns of DNA. So right now what we're looking at is the macro scale patterns in DNA. So there are three main regions that we're going to concern ourselves with. The first is the intergenic region. This is the part of the DNA between genes. Sometimes it has function, sometimes it doesn't, but it's not actually transcribed or made into DNA. And so along with the intergenic regions are the regulatory regions. These are the part of the DNA that tell the DNA when and where RNA should be transcribed, when a gene should be transcribed and made into protein. Finally, we have the gene. The gene is the part of the DNA that is actually made into protein, that it is transcribed into RNA and then translated into protein. And so this is really the functional component of your DNA. And as you may notice, this is actually drawn in a two-dimensional or even three-dimensional structure in this slide. And that's important. A lot of what you've probably seen is DNA being drawn in a linear line. DNA doesn't exist like that. It has to be fit into the nucleus. And so in its natural setting, it is conformed into a three-dimensional structure inside the nucleus. And so it's going to be important for you to start thinking about DNA as taking up three-dimensional space in the nucleus or the